Hello, everyone. Welcome to virtual open day of Lincoln School Mathematics and Physics. I'm Professor Andres Velendowski. I'm head of school, but I also teach in year one. I am joined today with two of our student ambassadors. I'll just let them introduce themselves. So, Henry.
Hi, I'm Henry. I'm a fourth year physics student currently doing my master's year.
Thank you. And Chris.
Yeah, I'm currently a PhD student at the university, but I was also an undergrad here before that. So I've been around forever.
Thank you very much. So, what we will be doing within this hour, I will tell you a little bit about some highlights about our school, and we will chat with Chris and Henry about those highlights. If you have any questions you want to ask, please put them in the comments of live chat on YouTube, and we will see them. We'll try to answer the best possible way. So, just a few words about math and physics in Lincoln. Uh, Lincoln is an ancient city, so it was founded by Romans, so it's a very old city. However, it has very modern university, and our school, mathematics and physics, is one of newest schools in United Kingdom. However, that means it's already 8 years old. So we have already graduates of all degrees, bachelor, integrated masters, research degrees, research masters, research doctorate degrees. And our graduates are having jobs not only in UK, but they also continue to study further afield, as we have our graduates, for instance, continue in Europe, in Finland, for instance. What is kind of special about our school? We are quite small school, so we have rather small classes. And what does it mean small? In mathematics, it could be 50, 60 students in a cohort, and in physics, it can be 20, 25 student cohorts. It depends year on year. When there are lectures, some students sit in their cohorts, and occasionally, if they study something like calculus, they sit together, mathematics and physics, so they can chat with each other and mingle with two of these cohorts. But then there are lots of classes where you solve problems, and then we split the students in smaller groups, like 20, and there is lots of, therefore, attention and a chance to interact with lecturers. And basically, it is impossible to get lost in a crowd if you choose to come to Lincoln. Our students, they know their lecturers, and lecturers know students. So there is quite a community feel, which is also supported by various activities which we organize in the school. When then was 2 years of pandemic, some of these activities been online, similar like this event is going online. However, as pandemic is fading away, we moved already all our teaching face to face, and we already started various activities. Last one was just a week ago. We had our physics movie night. We have various trips, and at the end of year we also have our end of year parties, which became very popular, where we celebrate achievements of both of students and also of lecturers whom students might, whose classes they might like. About our few words about our kind of degrees and what is special about our degrees. In Lincoln, if you choose either mathematics or physics, you have a full-fledged degree with with all main components of what constitutes of that subject. For instance, in mathematics, that includes very strong training in pure mathematics, strong training in applied mathematics, accompanied with training of computer languages. And we have computer module every year 1, year 2, year 3, and if you continue, year 4. And in physics, there's a similar setup. You have training in theoretical physics, accompanied with training in experimental physics, and also you have computer training. A special feature of our provision here in Lincoln is amount of project work which students can do, because mathematics and physics are subjects where you, as professional, expected to solve problems which maybe nobody solved before you. You could be the very first person who need to do something about a challenge. And that is skill we try to develop, and the best way to develop such a skill is actually try things yourself. In some of UK providers, you will find that there is a final year project. We have also final year project. In fact, if you on a 4-year degree, you will have even 2 projects in year 4, year 3. But we also have smaller projects on earlier years. In year 1, that is half module with name group study, where you split in groups of like 5, 6, 7 students, and there is a particular topic. And then as a group, you need to select your chair, report coordinator, literature search coordinator, whatever roles you might think are necessary, a minutes taker, and I produce report on that topic and have a group presentation on that topic. You use knowledge you already have in year 1 from main levels, and also what you already learned in year 1, and you work together with people whom you just met when you came to year 1. So that allows you to bond with your peers, but also develop skills on working in teams, as all employment nowadays is in fact in various teams where people work together. I'll just kind of ask our ambassadors if they remember what was their group study years back, and maybe they can say just a few words of what it was and what they like it about. So Chris and Henry, who wants to start?
I'll start, I guess. So the one that I'd talk about is my first year 1, where me and my group looked into the physics of the habitability of planets, which is a pretty huge topic. And for that, I was the engagement coordinator, which basically meant I was booking rooms and getting in touch with people outside of the group through emails. And it was good to sort of work on them networking skills. But within the actual project, I worked on what makes a planet itself habitable in terms of the weather and the sort of climate of the planet, which effectively meant going over to the library at Lincoln and picking out some geology or like geography book about climatology, which I didn't think would be a way that I'd go in my first year of physics, but it was really fun because I could extract every bit of physics out of that book and apply it to this project we were doing. And we were all sort of coming together, pulling these different sort of areas together to get this presentation at the end of it. And that was basically what I did for the whole time. It was good.
Thank you. Do you remember how many were in your team that time?
I think there was about 5 of us. So we had a few different jobs. One was looking at the applying our sort of method to Mars to see if we could live there. One was talking about orbits and how that affects it, and various different things. It was fun.
Thank you. And Chris, what was yours?
Well, so for my first year project, we did the physics of superheroes, which sounds like a slightly weird topic, of course, but it's very interesting to look at something that's maybe a bit weird, a bit sort of not what you'd usually think of in a physics classroom, and apply all the physics principles that you've learned in your mechanics class, things like that, to sort of these fictitious scenarios and see which could happen and which really couldn't happen. So that was first year, but actually the second year project I think was my favourite. So we did a lot of things in science now are interdisciplinary, which means you work with different fields. So we might work with chemists or biologists. So we had to work with a lot of chemistry technicians so that we could book lab time with XRD and SEM. So we could actually go over to chemistry labs and do those experiments and sort of write a report about that, which was very interesting.
Thank you, Chris. And what was kind of your favorite superhero from year one in that group study?
Well, that definitely has to be the one I wrote about for the report. So it'd have to be Iron Man, I think. In how that some of the technology is not really that plausible. Miniature arc reactor in your chest, probably going to kill you. But some of the things in the movies, so we looked at we sort of broke down a couple of scenes and things like that, and how they were sort of created for the film, and how they could perhaps be more realistic, like sort of your rocket propulsion and things. There is quite a lot of advancements in that field at the moment, so I would say that one.
Thank you. Yeah. So, as Chris mentioned, this topic might look maybe not very serious, but in fact, you need to write a quite serious report as starting physicist. Just starting first year, but it actually should use physics laws and explain why that is possible or not possible. In modern world, in fact, such professions, they already do exist. There are lots of science fiction movies, for instance, nowadays, and most of them come from United States, from Hollywood. And in America, there is a whole range of physicists who serve as consultants to movie makers to advise them that the movies look more or less realistic. And those people are qualified physicists, and they have quite interesting jobs to advise on all these various movies. The movie which we watched here in Lincoln last week with as our physics movie night was Interstellar, and some of you might have seen that movie. In fact, we have one of modules in a physics degree called Physics of the Universe. It's a third-year module, and it happened that that particular movie was discussed in lecture just a week before we had then in a movie night. So students could kind of check what they discuss in a class about realistic physics or not realistic physics, and then refresh it in a movie and chat with each other and also with lecturers about that that particular film. And Chris already came in discussing year two. So what I was telling that we have quite a substantial number of projects here in Lincoln. So not only classes, regular classes, lecturers solving problems, but also projects. And that means the first year project and a second year project. And before I continue second project, I see that there is already question, right? How good is the employability rate if you graduate in mathematics course? I'll come to that in a second. It's a very good question. Thank you, Luca. It's related, in fact, what I'm telling about projects. When people go in an employment, what employers look, they not only look what degree you have, like first, second, upper second, not only modules and marks, but nowadays employers pay a lot of attention what you can do yourself, because studying subject like a module and getting mark is a study. In work, you need to produce a product. So if in your degree you already have several opportunities to produce a product which is done during projects, that is always beneficial. And in our degree, we have those smaller, larger projects in every single year. And some students even can do, for instance, short research placement during summer, and or industrial placements also during summer. So therefore, having all these projects help our student to build a strong CV, strong skills. And for instance, in mathematics, we are very pleased that our mathematics students, in the latest statistics, it came that 95% have high skill employment after graduation. So that means then you graduate with a degree, you can have job, but what is important that your job is needs what you learned. So it's not just some job, but actually job which needs your graduate skills. And in our math provision is 95% of in statistics having highly skilled job, which is quite a high and pleasing number. And I continue with this discussing the project, why they're important. When you go to various universities, you can compare and check, how many projects they have. Usually projects are quite time investment from academics. However, we do that as we actually know they are beneficial for our students. So Chris already described what he've done as a second year project, which is also group project, but it's already whole module where knowledge need to be used which already gained during first and second year. And Henry, do you remember what was your second year group project? If maybe you can say a few words about yours.
Yeah, so ours is a similar setup to Chris's, I imagine, where it was about blending in these other disciplines. Ours was chemistry as well. We ended up collectively creating a primer, so like a text to help people use an SEM or scanning electron microscope. And for that, we sort of split up the different parts of like how it works, either like how you use it, how you get good resolution and sort of clarity of pictures, how you'd actually use the data produced. And we all had a certain job. And it ended up having this quite extensive primer that could realistically be used in industry. And I think that's a certain job that a physicist might get as well. So it's very handy. It's a very applicable to jobs.
Thank you. And if you talk about mathematics study, also all mathematicians, they have those group projects and group study. And in mathematics, it could be working as a team on a particular part of mathematical theory. If a project is more in a pure mathematics kind of inclination, or it can be where mathematics is applied in real life. It's called applied mathematics, and we have, for instance, very strong research in our school done in mathematics of flows. Then fluids or gases, they move in space. There is quite a complex mathematics involved. Some of this mathematics is not yet resolved. They even form of something which is called millennium, kind of a millennium problem about flow of fluids. So it remains a kind of mystery in some sense. However, many things are already known. As a result, for instance, we can fly in aircrafts, so all thanks to this phenomenon, and also thanks to mathematics, which can describe. So you don't anymore need to just do try and error when you fly, because it would be very costly, would cost life like in early days. Mathematics helps to calculate these things. And also, it's not only about airflow, but it's also about fluid flow. Our scientists in the school work on so-called nanofluidics, when you have various modern jet printers. They not just print on a paper, but they actually can print three-dimensional objects. And that requires a flow of plastic, complex plastic materials through nozzles, and in such way that it hardens in exact time that you get the object you want. All that is only thanks because of rather complex mathematics. Equations can describe how it all happens, and we have one of our leading figures, Dr. Claire McInroy, who is one of our UK and world experts in this particular part of applied mathematics. So again, if anyone has any more questions, please pass it. As we discussed with Chris and Henry, we will try to answer questions you might have. But I would like also to go a bit along this line of why our students actually get in such a good employability prospects. That is, of course, a kind of degree is composed of solid subject, but also due to all these special features like amount of project work. Another thing is amount of computer training. Very often jobs are in the world either directly in the computer companies, and we have mathematics, for instance, graduates working in one of world's largest computer companies. And that all requires very kind of strong mathematical skills. And also physicists nowadays can work in all these computer companies. And I just ask our ambassadors to comment on computer training you got during your degree, and Henry is still getting right now. So just if you say a few words, if you remember from year one and so on, any comment on your computer classes?
Yeah, what I'd say is it's quite telling because I'm currently in 4th year. I'm actually in the process of applying to a lot of like PhDs and thinking about where I want to go after university, which it probably seems quite a long way off for anyone watching. But we've talked a lot about all the things that could have potentially like boost your employability, and you could put it on your CV. And one thing that I always put down is the amount of computing we've done at the university. It's really kind of bolsters your CV to be able to put that you've used C++, you've used MATLAB, you've used Maple, you've used all these different languages, because it's what people are looking for now. I don't know how true it is, but people talk about data science being the 4th pillar of the scientific method. That's this long-standing sort of tenets. But for me personally, to be able to say that I've been doing computing consistently from the start of my university degree to the end is very appealing to employers. I think it's and just for my own confidence in computing, it's quite an intimidating subject, and I definitely feel like I can get stuck in with any kind of like computer scientist or whatever, at least understand what's going on. But yeah.
Thank you. You want to add anything, Chris?
I'm not sure what I can add to what Henry said there. I think the only thing I'd maybe mention, I mean, maybe I'm in the perfect place to, is one of the things we do at Lincoln is we have an associate demonstrator in our computing classes, which happens to be me at the moment. And a lot of students have said to me that they find it very helpful to have a perspective from someone who's also still a student, because I mean, I'm doing my PhD at the same time. Because sometimes there's a bit of a gap between sort of where a lecturer is at and where the students are at. And it's nice to have that sort of intermediary. I don't know if Henry can agree with that or disagree with me, but
yeah, definitely. Yeah, I get that as well. I've recently started doing demonstrating for year 1 labs as well, so I can sort of appreciate that as well. It's it's closing that gap, so you can be like, yeah, a few years ago I had this exact same problem that you had. This is how I kind of overcame it. Yeah.
Thank you very much. One thing which I want to kind of also mention, where our degrees we have a range of all possible kind of combinations. We have 3 years bachelor standard degree, and also we have integrated master 4-year degree, and sometimes students or applicants, they might not quite sure, okay, do I go for 3-year or 4-year degree? What if, which is better or worse? And in Lincoln, in fact, it doesn't matter which pathway you start, 3 or 4-year, you always can switch between these two trends, 3 or 4 years, provided, for instance, your marks are good enough. You started a 3-year pathway, you can continue to 4-year pathway, and other way around. You started on 4-year track, but due to whatever reason, you want to finish earlier. Then your exit award is bachelor honors degree, standard bachelor honors degree, as if it was your first choice ever. And that is achieved by a very simple trick that first 3 years are identical for both tracks. That adds this peace of mind that you have possibility to change at almost at the very last moment. And sometimes people ask, when is this last moment is? And best example, one of our graduates who is now in United States, and he is doing he's actually doing kind of assistant teaching jobs in university, learning more of teaching skills. He was on 3-year track and already was prepared to graduate in September, was traveling back from summer holiday in the United States back to UK for graduation ceremony, and then sent email to our program leader 1 week before graduation. Can I continue to 4-year pathway? Yes. And he continued to 4-year pathway and got graduated with integrated master. So that is a quite nice feature, I think, in Lincoln. Not all UK providers have the same first 3 years for both of the tracks. Commonly, first 2 years are the same, but third year is different. And usually difference is quite special. Many UK universities offer one final year project, either in the 3rd year or in the 4th year. And that difference make quite a difference. So if you been on 4-year track, you already on year 3, you have no project, and then you decided to stop earlier, then you graduate without having a project. In our case, it cannot happen. We have all this project on year 3, even if you continue to year 4. In year 4, you will have yet another project, and as a result, you have more project can list in your CV, and that is actually very beneficial. I think it's also important to say not just about subjects, but also about environment. Lincoln, as I mentioned, is very old city. It's also a very compact city, so it's everything walkable. And I'll actually ask our ambassadors to say a few words, how they found Lincoln City, what they like it, and about city, about campus, from a student perspective is the best information.
I can go first again. I suppose for starters, I love the city. It's amazing. I originally came from a small village just in the Midlands, and when I was thinking about universities I was coming to, I looked at some of the big ones like Manchester and Birmingham, and I was honestly just intimidated. Like, they're huge. Like, the cities themselves are massive. Everything's huge. I was felt a bit out of my depth. And then I stumbled across Lincoln, and I was like, it seems to have all the sort of benefits of them cities, while also, as Anjo says, being walkable and being honestly just a friendly place. Over lockdown, I was stuck in the city for for the whole time of lockdown. And given that I still absolutely love the place, I think that's sort of quite telling. The ability to sort of like walk out and go to like the Arboretum or to one of the commons out, huge like greenery just everywhere. It's just a very nice place, honestly. And there's not much else to say. I don't know about you, Chris.
I think one of the biggest advantages I found in first year has to be that you could roll out of bed 10 minutes before your lecture and still get there on time. Most of the student accommodation, certainly for the first years if you live in halls, is so close to the university, it almost surrounds it. And even when you move out to private accommodation in later years, it's not far away. The city is not that big. I mean, I now live on the outskirts, the opposite side of Lincoln, and I can walk in about 45 minutes. It's nothing compared to somewhere like Manchester or Liverpool, where you have to get a bus across. So that's, I think, quite a nice fact. But also, yeah, as Terry said, it's an absolutely lovely city. I've now consider this my home as much as I do where I originally came from. So.
And presumably also city has, as every city has all kind of other kind of features which for nightlife, for pubs. Maybe you can say a few words about this. It's an important part of being city. I think in Lincoln, nobody needs to take a taxi from pub to student accommodation. It's all walkable, okay, but still possible to take up, of course.
The best pub in Lincoln has still got to be the Pie Wipe Inn. Other pubs are available, but basically, there's this canal that runs through Lincoln, and you, on a really nice summer day, you walk up the side of the canal for 25 minutes, half an hour, and you get to this pub at the end. You sit down, have a nice cool drink, and then walk back, and it makes a really nice afternoon. I don't know if Henry's ever been there.
Yeah, I have, and I had a different experience. Also good, but I actually found that pub halfway through a run, and it looked so nice. I ran out the canal, and it looked so nice that I thought, yeah, this is time for a pint. And then I had probably one of the worst runs of my life on the way back. And I don't know, so it's a little bit tarnished, but it's a lovely place. If I still like the sound of the pub after that, then I think it's a good pub.
There's something for everyone in Lincoln, I think. I mean, obviously you've got the pubs and you've got the nightlife like every city does. But I think there's a lot of communities for anything you want to do in Lincoln as well. So, I mean, there's the football club if you want to go watch football. There's a couple of snooker clubs if you want to go play snooker. Anything you can think of doing. I mean, we've got axe throwing lanes and things now. Like, you can do whatever you want to do in Lincoln. It's really good.
Yes, and also kind of Lincoln is ancient city with a very modern university, and as a compact city with considerable size university, it's actually nowadays is a truly university city. So it's kind of they live together, kind of, and enriching each other. And while you are in Lincoln, you have benefits of being campus in the center of city. Just kind of 10 minutes walk from the center, like less than 10 minutes till train station. It's quite special. Also, campus sits on waterfront. It's a so-called Brayfoot Pool. That was already a port in Roman times. Now it is became quite touristic attraction area with a cinema on another side, restaurants, pubs, hotels, and university on another side. And it's in a sunny day in particular, it's really fantastic view. And 10-minute scroll, you inside of a very ancient city. And on the top of the Lincoln Hill, overlooking everything, there is a famous Lincoln Cathedral. Just mention a couple of words, not because it's just a cathedral. Lincoln was a place of what people think, some people argue, a person was the first English scientist. He was a medieval bishop of Lincoln of 13th century. His name was Robert Grotest. and why we think he was scientist. Of course, such a concept did not exist yet in the 13th century, but he left lots of writings about actually universe. He was trying to think about why rainbow is rainbow. The question, for instance, which scientists were trying to answer from Roman times. They only answered it in times of Isaac Newton, so centuries after this Bishop Robert. But he wrote about this. He wrote about geometry as well, about spheres and angles and stuff. And from these writings, we now think he was one of actually the first English scientist being in Lincoln. University holds a graduation ceremony in that cathedral, in Lincoln Cathedral, and reception ceremony after graduation in Lincoln Castle, also from early Middle Ages. I think Lincoln University graduation is one of most glorious looking graduations in the whole United Kingdom, in Lincoln Cathedral and in Lincoln Castle. I also want to kind of to say a few more words about science and math. We spoke about projects, and this project is not just to create just skills, but they actually can be related to actual research. And even outside of classroom, there are possibilities for students engage with research. For instance, our university runs annual undergraduate research summer placement scheme, where for about 6 weeks, students, 4 to 6 weeks, students can work alongside academic on some research project. And I don't know, Chris, Henry, did you have that opportunity? Maybe you say a few words about yours?
Yeah. So my project was with Dr. Martin Greenall from maths. And it was effectively, he had wrote some code that predicted the sort of the size that some molecules would form into these little vesicles, these little kind of balls, and the code would predict the sort of diameters and like the measurements associated with these. And my job over the summer was effectively to run this code with different parameters, making sure the code was still working, doing little tweaks here or there, effectively to try and reproduce some graphs that had been made a few years earlier, or maybe a bit further earlier, by actual experimental research. And it actually worked out quite well. And I'm lucky enough that the project actually is currently in review for publication. There's a journal entry. So I'm still waiting on that. But in terms of employability, that's amazing to be able to put that on your CV. That's definitely helped. But to be like to be part of that, it was very cool. Especially I was in my second year, so I can't say that I fully understood any of the like physics going on. But looking back after doing maybe my molecular modeling module in year 4, I can start like I've actually done it where I've looked back at the code and I can start thinking, oh yeah, that's from that bit that I did myself, and like it's very satisfying. It's very cool. It makes you feel like you're actually part of the sort of community, so to speak, scientific community.
Thank you. It is very special to have this not just this opportunity, but also when result might lead to publication. And we actually have several of such scientific papers now accepted with our undergraduate students. It doesn't happen often all over the kind of the places. So in fact, it shows that the science which students been also involved is of level that international referees accepted for publication as new science developed. So it is quite special recognition. And Chris, did you have that chance in your time?
I did, yes. So I did a Euros project with Dr. Matt Watkins, who's also now my PhD supervisor. But it was a lot less sort of intellectually involved, we should say. So we were developing educational resources for secondary school students. So obviously the level of physics was much lower, but I was using some of that coding knowledge that I'd generated in the computing classes. So we were using a mixture of Python and JavaScript to make a gas model and trying to educate them as to how the system kept its temperature and how the particles would move between boxes when you added dividers and things. So sort of a useful tool for teaching. But also you had to consider how sort of the limitations of your code, and in reality it's not going to conserve energy like it should, so you have to introduce like thermostats to the system and things, and all of that was really very interesting. And it's interesting to also look at a simple problem sometimes, because you have to work out how can I understand that in such a way that I can teach it to someone. It's sort of a whole different level of understanding, I think, when you have to teach it to someone else, especially when you've got to sort of aim that at a certain age group.
Thank you. Thank you. And it's also, by the way, good point to mention that some of employment in both in math and physics happens to be the school teachers. In United Kingdom, when you want to become a school teacher, first you get your main degree, and then you go for teacher training, another 1 year training to receive that teacher qualification. That can be done also in Lincoln, but also can be done elsewhere. However, when you get your first degree, you might not quite know, do you want to be teacher? To help students, in fact, with this kind of choice, we have an optional module in year 3, which is called mathematics pedagogy, and for physics degree it's called physics pedagogy. When students, if they choose that option, they can go to school and see for themselves what does it mean kind of to work in a school and try a little bit with skills they already developed. And that actually helps to have a more informed kind of opinion. Would be teacher's job something I would like to do? Because it could be that person thinks that likes to be a teacher, get degree, goes to teacher training, only after discovers that actually I don't like it, or other way around. So to have this possibility of option, then you go, and it's just 15 credits, so it's not huge investment. However, it gives very good taste of what this profession is about. And some of our students, in fact, got job offers straight after that module, and then actually continue as school teachers. So that kind of shows that when we design our degrees, and again, I mentioned that we are new school, we 8 years old, but in a scale of age of mathematics, thousands years old, or physics, hundreds years old, this is tiny amount, 8 years. But we designed a degree how it should be not 100 years ago, but actually now. We've thought about all this employability needs, computer presentation skills, ability to talk to people who may be not experts in your degree. We have even that skills training, and this is how it all kind of was created. And now we see it actually works. Our graduates are in various jobs, as I mentioned, not only in UK, but also continue further afield, United States, Europe. And this is how it is. So just maybe very briefly, just kind of maybe as a bullet point, mention what kind of scientific fields at the moment kind of feature in our school. Our school, of course, develops and new people arrive, so it's fluid, but nonetheless, in mathematics, we are very strong in pure mathematics. We have a research center, Charlotte Scott Center for Algebra. So algebra and group theory is the main specialty of this pure math group. Group theory is, roughly speaking, is mathematical constructions about symmetries in the objects around us, in the various patterns around us, but also more abstract symmetries inside of mathematical equations. We have people who are world leaders in that field, who also have, for instance, some of like theorems named after them, which quite high recognition. Then we have a large branch of applied mathematics, and Henry mentioned Martin Grindal, for instance, is a mathematician who applies applied mathematics, in fact, in physics. And this is where Henry done his summer placement. And this is applied mathematics broadly applied to very large class of materials. Materials all around us. There are all kinds of materials: plastics, metals, nanomaterials, and they all required lots of complex math. And this is where applied also mathematics is. That applied mathematics goes hand in hand with computational theoretical physics, also on material side. And this is where we have in physics Center for Computational Physics, with a range of materials from so-called soft materials, active materials, kind of live materials. It doesn't mean they have like a real life. It's just materials where particles have ability to self-move, and could be, for instance, a cloud of robots or cloud of animals. It's just one of exotic examples. And then computational theoretical part comes also hand in hand with experimental physics, also in material science, in nanomaterials, nanophysics, physics of nanoscale. And then from nanoscale, we actually go to huge scales. We have astrophysics research on one of most exciting part of modern astrophysics, about exoplanets. And our astrophysicist, Dr. Phil Sutton, just during last summer, was credited in a large group of scientists, 32 institutions, of which were only 2 from United Kingdom. One was us, and leading institution was NASA in America. They jointly discovered 4 new exoplanets. And also this research goes that these exoplanets, they might have moons, and these moons could be so large that it was the size of the Earth. And in fact, the life conditions could exist not on this planet itself, but on the moon of this huge planet. And it's very exotic research how you can do, sitting here on Earth, you can actually prove that there are those not just planets, but also planets with moons. And then you also can work on what could be weather conditions in these objects. And I just would like to ask again our ambassadors, who maybe would like to give maybe some advice to applicants who are looking on the places in university, what kind of things they might kind of better look for. Just any advice you want to give at the end of our chat.
It's a very hard question. I suppose it's, for me, it's all about like opportunities. Like, I suppose this is advice more for like while you're doing your degree, but like just saying yes to basically everything that comes flying at you, because you will get asked, oh, do you want to do this? Do you want to do this? Like, I had the option to do the EOS project. I took it, and I was a bit apprehensive at first because it's work to do over the summer, and it's your summer. You want to just do nothing, but I'm very glad that I did it. I also ended up doing some teaching. While I didn't do the pedagogy module, I did end up spending like 4 weeks in a school over last summer, which was a really good experience. It's another thing I could put on my CV. but it's all about just saying yes to things, even if unless you're sure you're not going to like it, but you're never sure you're not going to like it, so just say yes. But obviously that's something to look out for when you're looking at universities. Do they have these things that they're offering? Often if they're offering them, then they will mention, because they're good selling points. So if you don't see anything like that, then be skeptical, I guess.
Yeah, I think definitely take every opportunity that's thrown at you. And one of the good things about Lincoln actually for that is we have some dedicated people who will help you find, careers opportunities, careers advice. So you can go see them, talk to them. They're great, and they will steer you in the right direction at all times. And as Henry says, if someone comes to you and says, "Do you want to do a Euros project?" Yes, is the answer. And if you think of something you want to do, talk to the lecturers. They might be able to arrange that for you.
Thank you, Chris. Thank you, Henry. I think we kind of try to highlight to you what is kind of mood in our school is, and kind of atmosphere. And of course, the best thing would be if you would be able to come to see our campus, our city, talk to us. We still have the last face-to-face open day on coming Saturday. So if you can come, please do come. But also you can write us emails, and we will try to answer as fast as we can. And visiting city is really highly recommended from many people whom we spoke to. If person comes to city of Lincoln and also to our university, somehow they fall in love both with city and campus. That happens to me personally years back. Then I moved to Lincoln to get this job and open this new school. I did not know about Lincoln before. I worked in another UK city, and then I came and I was overwhelmed how nice and friendly everything is. And here I am talking to you, and I'm inviting you to come to see for yourself, and possibly to choose one of degrees we have in our school. And thank you very much for watching, and thank you, Henry and Chris, for chatting tonight about our school.